All right. Well, yeah. Thanks, Emma and Stephen, for having me, and for that lovely intro. I am indeed Andrew Kim, and yeah, let's get into it. I am currently working as a lead aquaculture research technician at Mossang Marine Labs, which, if you don't know, is a marine science graduate school administered by San Jose State University on the Central Coast, that awards master's degrees to students enrolled in Cal State marine science programs in the Central and Northern California regions. And I'm just going to talk a little bit about our bull kelp restoration project today that I've been a part of for the last few years. And I have a pretty good like half-hour talk in the can, I would say. But so, yeah, I figured before I get into all of that, maybe I could just share a little bit about my personal connection to kelp and kind of how I got to do what I'm doing right now, even though it's, maybe not all that interesting, but it's some good filler because we have an hour. Yeah, so growing up as a little kid, I didn't really, know about kelp or what kelp was. I didn't really think about kelp forests. I was not a good student. None of this stuff ever really occurred to me until I got to college. But being born and raised in Los Angeles as a first generation Korean American, my connection to kelp actually came pretty early, as they do for pretty much all Koreans, in the form of this soup pictured here called miyeokguk. Shout out Wikipedia for that lovely image. Miyeokguk is a soup that is traditionally eaten on your birthday. And yeah, it's not something you would normally see on Korean restaurant menus. It's kind of like a casserole, I'd imagine, just something that you wouldn't really find, but that is pervasive in Korean households. And it's made with undaria, which is also known as wakame in Japanese, and which is an introduced species on the Eastern Pacific where we are. And so, but yeah, kelp, it's like one of the first solid foods you eat as a little Korean baby. And it's not like some hot, new, trendy superfood that's on the rise. For Koreans, eating kelp is just a fact of life. And it's just an integral part of Korean culture. But yeah, for me growing up, it was just like this kind of weird, slippery soup I had to choke down a couple times a year. But I mean, I love it and crave it now, but yeah, back then I probably would have preferred a cheeseburger and fries on my birthday. But and I think my mom's actually on this call, so she might be able to attest to that. But yeah, that was basically the extent of my connection to kelp until I got to UC Santa Cruz, where I had no idea what I was doing, but I was flipping through the class catalog and read the class description for the kelp forest ecology field quarter, and which is a class where you'd have to get scientific diving certified, and you would come up with a project and conduct a field study. And it was just like, sounded so bonkers to me that that was a class that you could take for credit. And it wasn't long after that that I found myself swimming around in a kelp cathedral in North Monastery. And, if you get a chance to swim around in a kelp forest, it's just like a mind-boggling thing on a nice day. And yeah, those first few dives in the kelp cathedral are probably among, probably as close to a religious experience as I can get. And so I was pretty much hooked after that. I got certified as a dive instructor. I worked for a bit in South Korea and then came back and got a job working at Monterey Abalone Company about a decade ago in 2013, which at the time was one of 5 abalone farms in the state. Now it's one of 3. It's the only in-ocean abalone farm in the state, and it's a small operation located on the end of the commercial wharf in Monterey. And yeah, I got an obligatory otters on the farm image here. Yeah, and I worked there for almost 8 years as the manager, really overseeing all aspects of that business. And it was really kind of a dream job for a young naturalist. You're working on the water every day, you're in tune with the ebb and the flow, and you're surrounded by life. And yeah, abalone farms are businesses that really live and breathe with the kelp. And the only way that you can have an abalone farm is if you have healthy kelp beds nearby. And diving was a really big part of my job there. And during my time there, I felt the water get warm. I saw all the sea stars melt away and saw the urchins crawl out and saw the kelp get grazed. And I saw some, patchy but strong rebounds of kelp. But essentially, I just feel like I saw a system become a lot less stable in a relatively short span. And so, yeah, there's a nice photo of what driving a boat full of kelp looks like. And yeah, a lot of my skills and experience at the farm really has translated well into the restoration work that I'm doing now. Because working on the farm is like doing field work every day, basically. And so now I am, next slide, at Moss Landing Marine Labs, which has an aquaculture program centered around a 10,000 square foot outdoor shore lab facility, which is dedicated to doing research and developing sustainable aquaculture in the state, and doing research and development in the general field of aquaculture, in native species development, and a lot of research in climate change mitigation and resiliency. And we do a lot of work with restoration and conservation aquaculture, like the native Olympia oysters and the white abalone program. But yeah, I'm going to talk about our kelp restoration work today. So let's get into it. Why restore bull kelp? Well, yeah, so kelp forests, they're an iconic feature of the California coastline. It's home to one of the most biodiverse marine ecosystems on the planet. They're in decline around the world, and obviously that's alarming because of their importance as not only as a direct resource, but as critical habitat for commercially and ecologically important species. And it plays a key role in cycling carbon and nutrients, among other benefits, buffers ocean acidification. And yeah, but bull kelp is one of the two large canopy forming species of kelp that grows along the west coast here, and it ranges from the Aleutians to the central coast of California. This is a beautiful photo by Patrick Webster of a mixed bed with bull kelp in the foreground and some giant kelp in the background. Giant kelp is the other large canopy forming species. That's a cosmopolitan species, obviously has a lot more written about it. Bull kelp tends to occur in colder areas that are more difficult to access and grows in places that tend to be more exposed, and so they're just harder to study, and there's just a lot less written about it, a lot less work. But anyway, starting in 2014, a marine heat wave coincided with the outbreak of a sea star wasting disease, which wiped out this sunflower star from the southern part of its range, to the point that they're now IUCN red listed as critically endangered, and was recently reported as functionally extinct in California and Oregon. And this is important because throughout most of the range, they are the primary predator of the purple sea urchin. And so they're a keystone predator in the kelp forest ecosystem. And yeah, when the urchins were left unchecked, they crawled out of their holes, they mowed down huge areas of kelp forests. Yeah, you guys know the story. or at least have heard of it, probably. Yeah, and so it's been estimated that more than 95% of kelp was lost along the North Coast in the wake of this perfect storm of events. And these are some images showing that kelp loss at 4 Northern California sites. And yeah, all this loss has had a rapid and cascading effect on local ecosystems and the industries that rely on healthy kelp forests. And there was a lot of reaction and response from state and federal agencies and NGOs and nonprofits, tribal groups, scientists, and the general public. And things have happened like the red abalone fishery closure, which was an industry that used to bring in millions of dollars of revenue up to the North Coast every year. Disaster relief funds were made available to commercial urchin divers whose fishery collapsed, and emergency regulatory changes were made regarding the recreational take of purple sea urchins by CDFW. And so yeah, in the wake of all of this stuff, the statewide kelp recovery research program was developed to fund 6 projects meant to address research aimed at informing kelp management and filling critical knowledge gaps. And we were funded as one of those 6 projects, with our main objective being to test the efficacy of bull kelp enhancement techniques at a restoration site in Northern California. And so, yeah, aquaculture has an important role to play, and it's been identified as an action item by managers as a key component to developing restoration methods. And so I think aquaculture intersects with this issue in at least 3 obvious ways. We have the direct kelp enhancement. There's the possibility of predator reintroduction, which a lot of people up and down the coast are thinking about and working on. There's urchin ranching, which is the idea of taking these empty zombie urchins and fattening them up for food. Yeah, I'm going to talk about our little piece of this puzzle, that we've been working on, which is the direct kelp enhancement. And so testing kelp enhancement on the North Coast is important because it's largely untested. And recently there's been a lot of interest in green gravel as a potential cost-saving and scalable technique that's been shown to be effective with other species in other parts of the world. These are just some of the publications that highlight the emergence of this new technique. And so we set out to test green gravel along with other kelp enhancement strategies like diver applied direct transplants and spore bagging. And all of this work required the removal of urchins. And so, yeah, that's what we did. So to do all this work, we had to close the loop on the bull kelp life cycle. So here's an illustration of the bull kelp. This is a mature individual on the left. They can reach 25 meters from holdfast to nematocyst. The holdfast is this thing on the bottom that anchors the individual to the substrate. We got this long stipe and the gas-filled floaty thing up at the top that buoys the blades up to the surface so it can get its sun, do its thing. And bull kelp, like all kelps, exhibits a biphasic life history where it's got this diploid macroscopic stage called a sporophyte and a haploid microscopic stage called a gametophyte. They are an annual species, so it's absolutely critical for the species to reach maturity every year. So in other words, they need to go from being spores to making spores all in a year. We can sidebar a conversation about seed bank for you kelp nerds out there. But yeah, they have this unique reproductive strategy amongst the kelps in that they release their reproductive structures called through a process called abscission. And the sorus, which are these, the sorus is singular, they're sori for plural, are these structures that grow on their blades, and they're basically just these packets of spores that they release down to the bottom. And yeah, we needed to leverage all of these elements of their life history in order to, in the lab, in order to do bull kelp aquaculture year round. And so kelp aquaculture is well known and practiced in lots of places around the world, but standard practices are costly and labor intensive and may not work in a restoration setting. And so we basically entered some cheat codes and tried to figure out what we could get away with. We set out to develop a more pragmatic approach in order to have it be more scalable for restoration. And so we wanted to do kind of the bare minimum of what was needed to reliably produce kelp year round. And so we set up our tanks outdoors with ambient flow-through seawater and off-the-shelf cartridge filters from Home Depot and LED strip lights and shade cloth under really non-sterile conditions. And we've been able to reliably produce these sporophytes. And so for inoculation, it's basically a 3-step process. We bring in wild sori, we make this kelpie lasagna, and then we turn it into this kelpie soup. And then we pour that soup into our tanks with our various substrates, or directly into tank, or we inoculate tank walls directly to do our free-floating sporophyte cultures. And so here's a photo of some microscopic kelps growing in a sea of diatoms at about just over a month old. And basically a kelp forest growing on a tank wall. And once these guys get big enough that they can get tumbled around without flowing down the drain, they get scraped off the side of the wall, and they tumble around for a while. And then eventually their nematocysts get really big and they start floating around on the surface, and their stipes tangle together and they'll get like roasted in the sun. And so this is like the really cool thing that we have done, which is that we crown the kelp. And by that, we mean that we basically cut the nematocyst in half to make them neutrally buoyant again. And then they start tumbling around in these tanks, and eventually they start producing sori. And then we can use those sori to close the loop and start that over again. And so, yeah, doing this allows us to produce all life stages of the bull kelp year round. And yeah, it's been really great having this living sorrel bank. And yeah, this is that process of crowning the kelp. These are some little juveniles. You can see in the middle here a cut nematocyst, and then some sori that we produced in the lab. And yeah, this is a super successful technique for us. We can produce tens of thousands of free-floating little kelp blades with each inoculation for a really pretty low cost in these outdoor tanks. And so yeah, we used pretty similar methods for our green gravel inoculations. And you can see this beautiful photo of some of our more photogenic green gravel substrates out in the field. And yeah, there's a red urchin bag here for some foreshadowing. But yeah. Here's a nice photo of our outdoor culture system at night. So we took all of our substrates all the way up the coast, from the Monterey Bay up to Albion Cove in Mendocino County, which is where we did our work. It's about a 5-hour drive. And this is a photo of the site. In red is the area where commercial urchin divers were sent to do their purple urchin harvest. We put together a site within that removal area and a control site across a sand channel in an area where urchins were not removed. In green is the main benthic navigational line, and in yellow were our 30-meter lines where we drilled and eyeballed every 5 meters along the line, and we deployed our various treatments and conducted our surveys there. So we had a variety of treatments and controls. We had 2 sizes of green gravel. We did substrate bags, which were these bags filled with inoculated rocks. The idea here being that we could, that the little kelps could get enough light that the sporophytes could pop through the mesh while maybe deterring predation. We also paired those treatments with some unseeded controls. We also did some sporophyte transplants of our tumbled cultured individuals. And we had these sorrel bags, which we paired with our natural control plots where nothing was added. And so here is a visual representation of what the array of plots looked like at our sites. Each line contains a replicate of all of the treatments, which were randomly assigned, except for the sorrel plots, which were kept closest to the main line to minimize any potential halo effect from the spores. And so once we had our sites built, we returned once a month to conduct our surveys, which were done by clipping into those eye bolts with a 1-meter line and swimming it around in a circle and counting every purple urchin and red urchin, kelp recruits, and the substrates and the bags, among other things. Here is Dr. Scott Hamilton deploying some substrates. And we deployed these white substrates with our small things so that we could count and track movement in and out of our plots. These were the substrate bags and a sporophyte transplant, and here's a sorrel bag. So yeah, there's a lot of stuff going on, a lot of treatments, a lot of diving, a lot of infrastructure in this little cove, lots of questions. But yeah, before we get into the results, I thought this might be kind of a good place to just look at the timeline of our project and talk through some of the logistical issues and the challenges that might occur when you're doing work on the North Coast. So for an annual species like bull kelp, it's really important to consider the natural recruitment window of the kelp, which I've boxed some months in red of when you might expect to see that recruitment in the field. And our work began in June of 2021 with site assessment and initial surveys and beginning to build the site. The urchin removals began the following month and continued over the duration of our project. We had 3 outplanting events in September of 21, May of 22, and August of 22. And so, yeah, we put those first outplants out in September and really quickly learned that September is not when you should be doing your bull kelp outplanting, because October came around and just ripped out all the kelp and ripped out a bunch of our lines. We had to go out and do major cleanup. And so, yeah, in those winter months, we got busy in the lab setting up new infrastructure, and we continued to conduct our surveys, and continued to do our sorrel outplants. And early spring, we got the site back together and prepared all of our substrates for the big May outplanting, which was going to be our one really good shot to get this done last year. But the red urchins on our site had different plans. And yeah, most of our substrates just got almost instantly devoured by the red urchins on the site, which I'll get into in a little bit. But we had to scramble to get added to Reef Check's scientific collecting permit, which allows for the translocation of urchins so that we could get in there, remove the urchins off our site. So we reduced the red urchin densities down and managed to get another round of outplants out in August. But you know, by then it's kind of like we're towards the end of this recruitment window, and definitely not when you want to be doing your restoration up on the North Coast. So yeah, that was the timeline. This is kind of a fun little time lapse. It's an hour looking at one of our plots, and you can see our substrates in the middle here, and the red urchins are crawling around. And there's actually this really fun little interaction of this red urchin just bullying this purple urchin and stealing its piece of kelp. And yeah, so, you know, the purple sea urchins weren't the only grazers in the system. There's also like all these little snails crawling around, sucking on rocks. And yeah, lots of hungry mouths. Oops. Yep. So here's a photo of that same plot the next day with very clean substrates and some neat little piles of poop, and this like still hungry and waiting red urchin. So, yep, here's some more urchin destruction. Some results. So these are some figures showing urchin densities across both sites over time. What you can see is that the commercial urchin harvest works really well for reducing urchin densities, and there's a clear difference between purple urchin densities across the two sites, while red urchin densities are pretty similar. And if we zoom into just the restoration site, you can see this rapid decline in purple urchin counts in May following our 2022 outplanting, when the urchin divers directed their removal efforts like right around our plots. And then the drop in red urchin densities once the permitting came through for us to remove those red urchins. And here's a photo of what some of that urchin translocation looked like. We moved about 13,000 red urchins over to the south side of the cove, which was fun. And looking at our kelp counts, yeah, if we look at total mean kelp recruitment in our plots, there's a clear site effect with significantly more recruitment on the restoration side. So yeah, less urchins equals more kelp. And if we look at kelp recruitment in our sorrel plots versus the control plots, we see a clear treatment effect with significantly more recruitment in our sorrel plots over the controls. But there is an asterisk here, because a lot of that recruitment happened on our lines, which was totally unexpected. The kelp just seemed to really like the lines a lot. So we did a bunch of kelp transects, 2 by 30 meter transects along our lines, and we counted all the recruits on the line versus on the reef. And there was slightly more total kelps on the line. But when you think about kelp in terms of the density, in terms of the area available on the line versus the reef in this 2 by 30 transect, it kind of paints a more clear picture of kelp really liking the lines. And that could be due to the kelp itself being inaccessible to grazers, being lifted off the bottom. It might also just be able to withstand heavy grazing. The kelp, the structure of the kelp itself, there's just like lots of little crevices that the kelp can hang out in, maybe not get eaten. And so, yeah, at the end of it, we never had a single kelp survive on our green gravel in the wild. But after all of our stuff got grazed back in May of last year, we brought back a pile of substrates and put them back into our culture troughs. And sure enough, a couple months later, we had kelps growing on almost all the rocks that we brought back. And so we decided to do a kind of last minute substrate retrieval study, which has been which was really good. Yeah, we basically brought back substrates from both the control and restoration site, seeded and unseeded, mixed them all up by treatment and put them back into our culture troughs. And almost all of the substrates that we brought back popped up with kelp. And there was like these mini kelp forests growing on all of the substrates, which was pretty amazing, and kind of hopeful in that, maybe green gravel isn't, like it has the potential to work at this site. It can survive grazing. And that, yeah, the site wasn't really spore limited last year. And so these were some of the early results. We had some malaria actually, but mostly bull kelp on the site. And yeah, not much difference in the kelps popping up on our rocks post retrieval. Yeah, so really cool stuff. So what's next? We ran out of our sea grant funding to continue work at Albion, but thankfully the Nature Conservancy has stepped up and is supporting another year of restoration work in Albion to continue building on the years of work and mistakes and learning. And they've really taken on an active leadership role in this space, and they're really helping to keep up with the existing collaborations, and they're facilitating the new collaborations. And this year we're taking the stuff that we learned from last year and are exploring kelp on lines, and we're going to continue our spore bagging. These are some of the pictures of our indoor kelp nursery setup and the kelp on our twines. And yeah, there's just so many things about all this work that is unprecedented, this species in this environment, in using these methods, and just especially this like particular type of collaborative approach between all the groups. Like this isn't just a moss landing project, it's really a multi-agency and institutional effort. There's coordination between us and Reef Check and the commercial urchin divers and CDFW. And this year we're working with Brent Hughes and his folks at the Sonoma State University. And yeah, I'm hopeful that we'll keep learning from our mistakes and chipping away at this thing. And yeah, with all these great people working on it, I'm pretty sure we're gonna crack this nut and get some mature kelps growing in Albion real soon. So yeah, stay tuned for that. Oh yeah, and here's a fun little bonus. some images from the other day. Had this idea a while back that it might be cool to inoculate some urchin tests with bull kelp spores. So we did that about a month ago, and yeah, they're just like loaded up with these little baby kelps. Yeah, and these could be maybe a cool alternative to green gravel. There's a bunch of urchin tests going to the dump, and something kind of poetic about growing kelp on dead urchin shells. So yeah, that's basically it. And I think I have time for questions and lots of people to thank, and that about wraps it up for me.